Hi everybody. So your task at the end of the last video was to remember you were trying to find 201 in this list. You wanted to come up with an algorithm or just a set of steps to find this number in the list. Now, you can't just assume, oh, I found it right away, I'm done. Look, it only took me one step. No, you want to think about worst case scenario. You want to try and find a way that's going to simplify this. All right, find something that's going to work to search. So the directions were here. All right, and then I wanted you to share your algorithm here. All right, now I want to actually talk to you about another way to search. The first one that we talked about was linear, where you just search every item. So now we're going to, again, I wanted you to come up with your own algorithm, share that there when you turn it in. All right, now we're going to look at another one. So with this one, you find the middle number in the list. It has to be in numerical order. Compare that number to the given number. If the number is less than the given number, remove all the cards to the right, including the middle number you're on. If the number is more than the given number, remove all the cards to the left, including the middle number. Find the middle number in this shorter list and follow the instructions from step 1. And then you'll find the middle number of the new even shorter list and follow the instructions until you find your number. All right. So this is called a binary search. And you remember at the beginning of the year, we talked about binary numbers. It does come into play here. All right. So if I'm looking for 705, again, I want to start in the middle and I want to compare it to the middle number. Again, it does have to be in numerical order. They're not equal. Step 1. All right. Since it's larger, I'm going to get rid of everything from here over. So my new list is just going to be these 3 numbers. All right, so now we're just focusing on these 3. So again, I compare it to the middle number. Step 2 is comparing it to the middle number. Since it is less than 716, I'm going to throw out everything from here to the right, anything larger. And then I'll compare it to what's left, which would be our step 3. And we've found our number, and we've gone through every card. All right, so with 7 numbers, that only took us 3 steps, where if you had to look at every single one, it would take you 7 steps. So let's think about this list. Oh, I wish that 75 didn't cut off, but whoops, that's okay. Come on. So it says list the steps using a binary search to look for the number 32 in this list. All right, so first of all, I'm going to adjust that so it's up there. Okay, so we're looking for 32. Okay, 32 is our number. So we want to find the middle of the list. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the 8th number is our middle term. So we're going to compare 32 to the number 25. Okay. Is it equal to 25? No. It's larger. So that means we're only now going to look at the numbers that were larger than that. So my new list is that. Okay, so now step 2, I'm just going to copy and paste this. Step 2, we're now going to compare 32 to the middle number in this list, which would be 47. All right, so is 32 bigger or smaller than 47? It's smaller, so I'm going to get rid of everything from here over. So now I'm just looking at these 3 numbers. Okay, getting down there. So again, we started with 15 numbers, and right now we have only had 2 steps. So I'm just going to copy that, paste it. So step 3 now, we're going to compare 32 to the middle number, which is 33. Oops. And it's less than 33, so I'm going to toss 33 and 45 out the window. I'm left with 32. So my final step is to compare 32 to that number. They're equal, and you're done. And that was the last number in the list. That would have worked for any number in here, all right? The maximum number of steps that you would need for that number of items in this list is 4, all right? So what's the third step in looking for 32 in that list? Comparing it to 33. Choice B. Okay? So let's take a look. So I don't think I have to do any more editing for now. So we'll take a look here. So it says do this. Now try the binary search algorithm for different instances. We've done a few for you. Copy the instance table for your journal. Well, you don't have to do this. This is if we had class this year, and plot the points. So we can do it together on here. So if you had one number to check, there would only be one step. It either is or it isn't. Okay, so there's that point. If you had 3 to check, well, you would check the middle, and then it would be either bigger or smaller. So you'd have to check the middle and then check either the bigger or smaller one that was left. So you would have 2 to check. And if you wanted to, you could look back at this one. There was 3 to check. We would check it here, and if that didn't work, we would check it here and here as well. But the most it would take is 2 steps. Oops. If you had 5 to check, you would check the middle. Then you would check either above or below it. And you'd have 2 numbers to check either above or below. So you would have a total of 3. If there were 7, there would also be 3. All right, we just did 15 and there was 4 steps. If you had 9, there would be 4 steps as well. All right. So I want you to think back to Unit 1 when we were talking about binary numbers. Remember, we just used zeros and ones. And how that chart worked was this column, 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, and so on. It's 2 because of binary, it's either yes or no, right? When you just check those numbers, yes, it's equal, no, it's not equal. All right, so with this, if there's one solution, there's going to be one step. If there's 3, 1, 2, or 3 solutions, now you're going to have 2 steps. If you have 4, 5, 6, or 7, right? Because it could be 4. It could be 4 and 1, which is 5. It could be 4 and 2, which is 6. Or it could be 4 and all of those added together. If there's up to 7 different cards or different numbers to choose from in your list, then you would have 3 steps. Once you hit 8, now you're up to 4. And it's going to stay at 4 steps until you get to 16. All right, then there will be 5 until you get up to just up to 32. All right. So there's a little bit of a pattern there. If you tried those with the cards, that same thing would happen. All right, so just keep that in mind when we're working through here. It all is kind of connected. All right, so the 2 search algorithms we've explored so far. The first is linear, which means you check every single one. So the more items there are, there's that same number of steps in your search. The second is the binary search. and it grows at a much slower rate because basically you're just cutting it in half each time. All right, so the binary search most of the time is going to be your more efficient algorithm to use. And again, that's just one. There's so many different ones. If I had one input, which algorithm would I use to get my answer with the fewest amount of steps? It wouldn't matter. Either one would be the same. If you had 5, binary. If you had 100, binary, okay? Because if it was linear, you'd be checking every one. There'd be 5 steps as opposed to 2, okay? All right. So again, efficiency is a measure of how many steps are needed to complete an algorithm. A linear search checks each element in a list in order until the desired value is found, or all elements have been checked. And then a binary search is a search algorithm that starts at the middle and then removes half the data and then checks the middle again until, again, either you found your value that you're looking for or all the elements have been eliminated. And that's it. Okay. You do not have questions on code.org for this one. It was just this video and filling out the different parts of this. Some of you will just be doing it with me in class together, so you won't even have to worry about this. If you have any questions, as always, just send me an email or stop by Virtual Math Lab. Have a great day.